Alright guys, so here's what we're going to do in this page of the notes. I want to kind of flash back to Algebra 1 with you and remind you why. In Algebra 1, anytime we came across the square root of a negative number, we just simply said that it was undefined. Now, and here's the reason why. Remember with me, when you take the square root of a number, what you're looking for, your answer to the square root of a number, is the number, right, that when you square it, gets you what's under the radical. For example, if I were to ask you to find me the square root of 4. Well, you guys know this one. It's an easy one. The answer is 2. But what does that mean? Well, what this is telling you, right, is that if you were to take a 2 and square it, 2 times 2, you would get 4. What was under the radical. So anytime you take the square root of a number, your answer is the number that when you square it, gets you back to what was under the radical, or what we call the radicand. All right, 4 represents the radicand. Now, here's why we said in Algebra 1 that the square root of a negative number was undefined. When you square a number, what you're doing is you're taking the number and multiplying it by itself, right? The same two numbers, absolutely identical, you're multiplying them together. Let me show you how this works. Let's just say, for example, that I'm looking for the square root of a negative 16. Right here, negative 16. So I want to find the square root of negative 16. Well, what that means is I'm looking for a number that when I multiply it by itself, I get negative 16. Well, let's go ahead and try a couple of options. I could do a negative 4 times a negative 4. Right, that's identical numbers. Negative 4 times a negative 4, because those numbers, they have to be the same number, right? Anytime you square a number, you're multiplying it by itself. So they have to be identical. So a negative 4 times a negative 4, but when you do that, the negatives cancel each other out, and you wind up with a positive 16. I didn't want a positive 16, I needed a negative 16, so that doesn't work. My other option would be to do a 4 times a 4. Those are identical numbers. But again, a positive 4 times a positive 4 gets me a positive 16, and that's not what I was looking for. I was looking for a negative 16, so that won't work. It turns out when it comes to multiplication, the only way to get a negative number is to multiply a negative number by a positive number, a negative 4 times a positive 4. This does get me the negative 16 that I was looking for. However, it doesn't satisfy my definition of a square for this reason. These numbers have to be identical, and they're not. I have a negative 4 and a positive 4. That's not the same number. Those are different numbers. Negative 4 and positive 4 are not equal to each other. Therefore, I don't have identical numbers, and I have not satisfied my definition for a perfect square. So it turned out that there are no two real numbers that can be multiplied together to give you a negative number. And hence the reason why in Algebra 1, we told you guys that the square root of a negative number was undefined. Because there are no two real numbers that when you multiply them together will get you a negative number. So what we're going to do here in Algebra 2 to deal with this issue is this. We now want to define the square root of a negative number. And here's how we're going to do it. We're going to go ahead and by definition say that the square root of a negative 1 is equal to I. And of course, I just simply stands for imaginary. So we have here now a definition for the square root of negative numbers. We're going to call it I, the imaginary number. One quick note here, just an extra little piece of information that will be very important when we get to problems. Notice this. If I have I, oh, sorry, hold up, that's my highlighter. No, I don't want that. If I have I is equal to the square root of a negative 1, and I were to square both sides, I squared, which means I have to take the square root of this side as well, or square this side as well. Well, remember, we just looked at that property from Algebra 1 that says anytime you square a square root, they cancel each other out. And what you wind up with is I squared is equal to a negative 1, which is the second little piece of our definition here. I squared is equal to a negative 1. And that's where it comes from. So now what we're going to do here in Algebra 2 is, instead of saying when you come across the square root of a negative number, instead of just saying it's undefined, we're going to go ahead and use this definition to introduce this idea of imaginary numbers, because we're looking for solutions to quadratic equations, and some quadratic equations have imaginary solutions. You wind up with the square root of a negative number, and now we have a definition to help us deal with those particular quadratic functions when we come across them. So let's go ahead and take a look at how some of these are going to work on the next page of our notes here. In Algebra 1, when we would have gotten to these problems, we would have just simply said that, hey, these are undefined, you can't do them, and we would have had to have moved on to the next one. But now let's go ahead and use the definition that we just got to see how these work. Okay, well, here's what I'm going to do. I know that in order to solve this problem, right, I'm asking you to, I know, I say simplify. Cross out that simplify. That may not have been the right word. For all of these, we want to solve. I want you to solve for x. So we need to get the x by itself. We need to isolate the x. So let's go ahead and do that. I have x squared is equal to a negative 4. Well, to get that x by itself, I would simply take the square roots of both sides. Don't forget to do plus or minus whenever you take a square root. So here's what I've got. The square roots and the square cancel each other out. Plus or minus the square root of a negative 4. Now again, in Algebra 1, we would have just simply said that that was undefined. But here what we're going to do now in Algebra 2 is we're going to use our definition and the properties of exponents, the properties of radicals that we saw on the first page of the notes to split this guy up. I can rewrite this as the square root of 4, times a negative 1, and then the property, the multiplication property of radicals to take the square root of each of those separately. Plus or minus the square root of 4 times the square root of a negative 1. Well, here's what we've got. I can take the square root of 4. Square root of 4 is 2. So I get plus or minus 2. And on the previous page of the notes, we just saw that the square root of negative 1 we have now defined as I. So I simply call that an I, and my answer is x equals plus or minus 2i. And what I have are imaginary numbers. This is going to be plus 2i and minus 2i are two values in my imaginary number system. So let's go ahead and try another one of these. And at this point, feel free to work ahead and then come on back and check your answers with mine. Again, I think you probably get the hang of these pretty quick. Let's run through these next ones here real quick. I got to take the square root of both sides. So when I take the square root of both sides, the square and the square root cancel each other out. I'll be left with x is equal to plus or minus the square root of a negative 9, which I can split up into 9 times a minus 1. So this is going to be x equals plus or minus the square root of 9 times the square root of a minus 1. Well, I know the square root of 9 is 3. So plus or minus 3. And the square root of a negative 1 is I. Right? See how simple these are? Piece of cake. Move the 27 to the other side, and I wind up with x squared is equal to a negative 27. take the square root of both sides, and x is equal to plus or minus the square root of a minus 27. Well, we can split that up into plus or minus the square root of 27 times the square root of a negative 1. Okay, hold the phone. 27 is not a perfect square. That's okay. We saw what to do with this on the previous page of the notes. We're going to split 27 up into factors where one of those factors is a perfect square, and here's how we're going to do it. X is equal to plus or minus. I can split 27 up into 3 times 9. Square root of 3 times 9 times the square root of a negative 1. Well, there we go. The square root of 9 is 3. So I have plus or minus 3. Can't do anything with the square root of 3. It's an irrational number, which means I just leave it written in radical form. Rather than write out the decimal, the non-repeating decimal, which you couldn't do. It goes on to infinity. You'd have to round, and ain't nobody got time for that. So we're just going to leave it as the square root of 3, and then the square root of a minus 1, by definition, is I. And that is as simplified as you can possibly get. X equals plus or minus 3 square roots of 3i. And again, remember what this means. You're getting two answers. It's quadratic. You have to have two roots, right? The quadratics cross the x-axis in two spots. What are my two zeros or roots? What are my two solutions? Well, one of them is x equals a plus 3 times the square root of 3i. And the second one is x equals a minus 3 times the square root of 3i, right? So for every single one of these, I'm getting two solutions, and that's because when you take a square root, you get plus or minus the answer. One more here for you. Oh, I apologize. Two more. Again, same thing here. I've got to move that 18 to the other side, so x squared is equal to a negative 18. X is equal to plus or minus the square root. Okay, 18 is not a perfect square, but that's not a problem. I can split it up into something that is. Split 18 up into 2 and 9, and of course I pull out my square root of a negative 1 because that's my definition of I. And we go ahead and do that. So x is equal to plus or minus. The square root of 2, again, is an irrational number, so we'll leave it as the square root of 2. But the square root of 9 is 3. So 3 square roots of 2, and the square root of a negative 1 is I. And there's my two answers. And one more for you here. X squared is equal to a negative 64. That one's easy. 64 is a perfect square, so plus or minus the square root of negative 64 means that I have x is equal to plus or minus the square root of 64 times the square root of a negative 1, which means x is equal to plus or minus 8 I. Plus or minus 8i. So, guys, hopefully that makes sense. And again, it is a little different than what we did in Algebra 1. Again, in Algebra 1, whenever you came across these square roots of negative numbers, we just simply said, hey, that's undefined. Don't worry about those now. Here in Algebra 2, now we have a definition, a way of dealing with those square roots of negative numbers. We're going to define them as I. And we wind up with these imaginary numbers, these numbers that are part of the imaginary number system, which we're going to work with now for the remainder of this, section and the rest of the videos to follow. Guys, head on over to the next page of the notes, and I'll meet you there.